Yes, good day everyone. This is Mr. Olushola Ogunlana, a website developer and also an expert in mathematical tutor. So I'm also a graphic designer and a digital marketer. So today I'm going to share with all my students across the world on a topic which says circle geometry. So we're going to start the lesson. Actually, the topic is for all senior secondary students, that is age range from 13 to 16. So as for parents, you can just download it for your children so that they can learn from it at home. So let's start the lesson, circle geometry. Before we go into circle geometry, let me explain what the circle means to all of us. Circle simply means any round closed object. Let me show you the diagram of the circle. This is a circle, it's a closed round object, and that's the name in the middle. Circle, a circle. Now let's continue. Before we go, let's look at the parts of a circle. We have many parts, many particles inside a circle, ranging from diameter, radius, segment, sector, and the rest. So let's see them in pics. So as you can see, this is a complete circle. Now this is the center of the circle, that is the middle. You can see it marked up. And now any line that runs from one part of the circumference to other part passing through the center of the circle is called a diameter. A what? A diameter. Look at the diameter here. Diameter is this line that runs from one part of the circle to the other to the center. Now, the one that runs from the center to any part of the circumference, that is this very one I'm pointing at, that one is the radius. That is the radius. Right in this circle now we have how many radii? This is 1, 2, 3, and 4. So any line that runs from the center to any part of the circumference is called radius. Having said that, another line here, which is a straight line that divides a circle into two unequal parts, is called chord. I come again. Any line that divides a circle into two unequal parts is called a chord. Look at the name, chord. C-H-O-R-D, chord. Now, the region that is occupied by two radii and an arc, as I'm highlighting it, this particular region that is being occupied by two radii and an arc is called a sector. That is a sector. The whole of this portion is called a sector. We call it, this one is a minor sector and the other part is the major sector. So that is sector. Now, there is a particular region too that is being cut out by the chord onto the circumference of the circle. That part that is being cut out, that is this particular part, is called a segment. Segment, look at the name, segment. Segment is that portion that is being cut out by a chord to the part of the circumference of a circle. Having said that, there is another part that is very important, that is the circumference. That is the distance round the circle. Distance round the circle is a circumference. You can also call it a revolution. It's a complete revolution. But as far as this circle geometry is concerned, we are going to refer to it as circumference. Look at the circumference. Is the line that is being depicted with color purple. I'm sorry. So that's the circumference. Now, there is another one, arc. Arc is just a small part of the circumference. A small part of the circumference is called an arc. Look at it. It's a small part of the circumference. Now, the other thing that I have not mentioned is the tangent. Tangent is a line that passes through the circumference of a circle. It passes through the edge of the circumference of a circle. That's what they call tangent. As we go in the lecture, you will see many of these terms in it. So let's continue. So now you've known the parts of a circle. So let's continue to what we call geometry. Geometry means any line, any drawn object created with lines. Anything you draw created with one or more lines is called a geometry in mathematics. Now, the circle geometry itself simply means any object drawn inside a circle. When you have any object drawn inside a circle. So let's continue. Now, we're going to theorems of circle geometry. Those are the theorems that bind all circle geometry together. You can use these theorems to solve any circle geometry questions that you are given at any time. So theorem 1 says, angle subtended by the diameter at any part of the circumference is 90 degrees. Angle subtended by the diameter at any part of the circumference is 90 degrees. Let's look at it. So this is a circle. You can see this is the center of the circle. This is the diameter. Now, the diameter subtends this particular angle at the circumference. So that is what we are talking about. Any angle subtended by the diameter at any part of the circumference is 90 degrees. It's equal to what? 90 degrees. We can also call it a right angle. So that is theorem 1. Now let's go to the second theorem. Theorem 2 says that angle subtended at the center of a circle is twice angle subtended at the circumference. That one simply means any angle subtended at the center is 2 times angle subtended at the circumference. So let's see that example too. Okay, are we together? Yes, okay. Now, look at this circle. Angle A is subtended at the center of the circle, and another angle is subtended at the part of the circumference. Look at this. The one subtended at the circle is labeled what? A, and the one subtended at the part of the circumference is called what? 2A. That simply means angle at the center is 2 times angle at the circumference. That is your theorem number 2. Now let's go to the third theorem, which says angle subtended at the same segment are equal. Angles subtended at the same segment are equal. Let's look at that. Angles subtended at the same segments are equal. Look at this particular circle now. You can see all these angle A, they are on the same segment. So look at it. A is equals to A, and A is equals to A, and is equals to another A. So all those 3 angles are equal because they were subtended at the same segment by the same in the same circle. So whenever you have any angles like this in the same segment, they are equal. So that is our theorem 3. Let's go to the fourth theorem. The fourth theorem says opposite angles in a cyclic quadrilateral is sum to 180 degrees. Opposite angles in a cyclic quadrilateral is sum to 180 degrees. Let's look at that. It's also here. This is what we are talking about. This is any 4-sided object inside a circle is called a cyclic quadrilateral. Now, what we're talking about is this opposite angle. A is opposite B and X is opposite to Y. So AA plus B give us 180 degrees, while X plus Y give us 180 degrees. That's the meaning of the theorem. So when you sum the opposite angles together, you get 180 degree. This is what we're saying. X plus Y is equals to 180 degrees, and A plus B is equals to 180 degrees. So now let's continue. The fifth of the theorem says angles subtended by two radii are equal. Angles subtended by two radii are equal. Look at the two radii. Opposite is radius. Opposite of radius is radii. Look at radius 1, radius 2. And another thing they use to depict any equal angle in mathematics is by the use of bar. Look at one bar here and another bar there. Whenever you see any angle that is being marked single bar or double bars, it simply means those base angles are equal. Like in this case now, A is equals to A because they are all subtended by two radii of the same circle. So that is opposite, angles subtended by two radii in a circle are equal. So now that we have learned the given theorems, let's go to the exercises. Okay. So now the exercise 1. Let's start from number 1. From this question number 1, we can see that we're given a circle and a diameter, and I told you that angle subtended by the diameter of a circle at any part of the circumference is 90 degrees. That simply means this angle down here is equals to 90 degrees. So our solution is going to be x plus 52 plus 90 degrees is equals to 180 degrees. 180 degrees is the sum of angles in a triangle. Sum of angles in a triangle is equals to 180 degrees. So now, therefore, our x plus 142 degrees is equals to 180 degrees. So our x now will be equal to 180 minus 142. So our x will be what? That will be 38 degrees. Our x is 38 degrees. That's solution 1. Hope it is clear to everyone. If it is not clear to you, I will drop my details at the end of the video. You can contact me through the phone number there or the email. I will quickly attend to your questions. You can also go to the comment section and let me know where you are having issues and any of the solutions or the explanations. Thank you. Let's continue. Solution 2. We have a circle given with a four-sided shape, which I call a cyclic quadrilateral. Now, the first part you calculate here is the . Solution 2. The first part we calculate here is the angle C, because C and 92 degrees are on the same straight line. So we can say that C plus 92 is equals to 180 degrees. That is sum of angles on a straight line is equals to 180 degrees. Now, our C will be equals 180 minus 92. So our C will be equals to 78 degrees. So having calculated our C as 78, we move to A. We should remember that A plus C is also equals to 180 degrees from our theorem.
88. 88 degrees.
No, 70. Okay, this is 88 degrees. Yes. Thank you. So now A plus C is equals to 180 degrees from our theorem, which says opposite angles in a cyclic quadrilateral is sum to 180 degrees. So we now have A plus 88 is equals to 180. So our A now will be 180 minus 88. So our A will be equals to 92 degrees. So now remaining our B. Similarly, B plus 85 is equals to 180 degrees. The reason is the same thing as the one above. Opposite angles in a cyclic quadrilateral is sum to 180 okay, 180 degrees. Hope you are following. So our B now will be 180 minus 85. So our B will be equals to 95 degrees. I think with this we are through with the solution.
92 degrees.
95.
92 degrees.
Yes. So I think we are through with the solution 2. So let's go to solution 3. So solution 3, this is exercise 3, example 3. So let's see the solution. This is theorem 2, which says y here will be equals to 2 times 33 degrees. Theorem 2, which says angle subtended at the center of a circle is twice angle subtended at the circumference. Now, our y will now be equals to 66 degrees. That's our solution number 3. So let's go to solution 4. Question 4 says, look at it by the side. This is angles subtended by 2 radii in a circle. And I told you that the angles subtended by 2 radii in a circle are equal because radius is the same all over the circle. If you draw a line from the center of the circle to any part of the circumference, it is called a radius, and it is the same throughout the circle. So right now, our S is automatically equals to 42 degrees, and the reason is angles subtended by 2 radii. Yeah, radii, yeah, in a circle are equal. Now, remaining our t, and we should know that t plus 42 plus another 42, that is S and 42, everything equals to 180 degrees, because sum of in a triangle is equal to 180 degrees. So therefore our t plus 84 is equals to 180 degrees. Our t will be equals to 180 minus 84. So our t equals 96 degrees. So we are through with solution 4. So let's go to example 5, which is solution 5. Let's see the question 5. Solution 5. We can see that all the angles in this circle were all subtended at the same segment. Like I told you that angles subtended at the same segments are equal. So therefore, we can say that V is equals to U, which is equals to 41 degrees, because angles subtended at the same segment are equal. So therefore you can say that your UV is equals to 41 degrees, and the U is also equals to 41 degrees. So we have come to the end of today's teaching, and I told you it's all about circle geometry, and I believe you all have immensely learned from the lesson. So let me drop my contact here.
Subscribe.
Number one, after watching this video, make sure you subscribe under it so you can have access to more exciting videos coming soon. Then my contacts. You can contact me on 081 3801 4703. Email olushola.ogunlana@gmail.com. So also remember
To like and share the video.
to like and share
And also download.
the video. You can also download it for your children.
No, for your children.
Thank you all. You are also free to write your comments under the video.
Yeah. Why?
So,
You know this face.
once again, thank you all for watching my video. See you next time.